Hi, my name is Thomas LaCurse. I'm a second year electrical engineering student at Lassonde, and I recently just finished taking up a course called EECS 2210. Now, EECS 2210 was a course where we learned about microelectronics, the fundamental components, the diodes, transistors, MOSFETs, and op-amps. With the knowledge that we gained from this course, we can use these components to build more complex systems. And for my project, I decided to do it on a VU meter. Now, let's see what a VU meter is. Now, a VU meter just stands for volume unit meter. So you can supply this circuit with any audio signal, like one from your phone or laptop, and then that gets fed into here. And then from this, the op-amps will differentiate if the signal is either loud or quiet, depending on the voltage it receives. So then it'll output voltage to these rows of LEDs corresponding to the loudness. If it's very loud, all 7 rows will light up. If it's not very loud, only 1 row will light up. So now, let's get into the actual operation. So here you can see our audio input in the first audio amplifier stage. We have our right and left channels. Those get mixed into a mono signal output. Then we have a potentiometer to adjust the audio signal. This can be useful if we have different devices being plugged into this, which output audio at a different peak voltage. My iPhone appears to output at around like 170 millivolts, so we have that set to provide a gain where the output of this entire system is 8 volts peak AC. Now, from here, we have to decide whether it's loud or quiet. To do this, we have 7 op-amps which operate as a comparator. So to do this, we used a voltage divider to define voltages that can be used as a threshold. So if the audio signal coming in from this first stage is greater than any of these voltages, that row will light up. So let's say I have my output from this stage is 5.5 volts. That means we'll get an output of 12 volts to the gate of the MOSFET on row 5, 4, 3, 2, and 1. This in turn ends up turning on these rows in the LEDs. So now let's see this actual working with the song. So when I turn on a song on max volume, we start to see the LEDs light up. And according to how the song goes, it can either start out loud, quiet, depending on whatever it is. As you can see, it's starting to light up more and more. The song's getting progressively louder. To even further test this, we can use a constant tone from YouTube. So let's just look up constant tone. What this does, it'll provide a stable output at a certain frequency. So if I vary the volume in my phone, you can see the LEDs start to decrease as I decrease it, or increase back up to max. And there you pretty much have it. That's the whole circuit. It just relies on 8 op-amps. 1 op-amp amplifies the main audio signal, which is fed in by this audio jack. Then from there, we feed this signal into these other op-amps. These op-amps are comparators, which, if it's past the threshold value, will supply 12 volts to the gate of this MOSFET, and then turn on the corresponding rows of LEDs. And it's that simple. And that has been my project. So overall, this has been a fun project to actually apply the knowledge that we learned in class to actually build something in real life. It gives us real practical knowledge of what to do with these components. Okay, thank you for watching, and I hope it was entertaining.